All right, this is 7B notes. We're going to be graphing rational functions. All right, the following guidelines you need to memorize. Let's go through them. Let's read through them first, and then I'll show you an application of each of these. All right, a removable discontinuity. This is a hole in your graph. It occurs when your numerator and your denominator have a common factor. Non-removable discontinuities is a vertical asymptotes. It's the zeros of the denominator once you've removed your common factor, if there is one. All right, horizontal asymptotes. And I'll show you an easy way to find these as we go through these. But your horizontal asymptote could be, like for A, if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator and the degree of the denominator are the same, then it's going to be the ratio of the lead coefficient of the numerator over the lead coefficient of the denominator. And then C, if the degree of the numerator is greater than the degree of the denominator, there's no horizontal asymptote, but there may be a slant asymptote. And like I said, I'm going to show you an easy way to find these as we go through our examples today. All right, x-intercepts, it's the zeros of the numerators. Here again, once the common factor has been removed, the y-intercept is the value of f of 0 when x equals 0. And here's 6, slant asymptote. We're going to look at this on the next set of notes. But it occurs when the degree of the numerator is exactly 1 more than the degree of the denominator. So in the example here, here's a rational function. The degree of the numerator is 2, where the degree of the denominator is 1. We're going to do long division to find the equation of the slant asymptote, and it's always going to be linear. All right, so let's look at our first example. Now these are different than what you did in your 7A notes. All right, in 7A notes, they were in general form. These are not. All right, this is going to be in rational form where you have a numerator and a denominator. All right, take a moment, and if you need to, pause the video and write down the following steps. So step number 1, we're going to factor. We're going to factor our numerator and our denominator. So we're going to get x minus 3 times x plus 3. And then our denominator, what multiplies to give us negative 3, but has a difference of negative 2. That's going to be x minus 3, x plus 1. All right. Now look at this. Notice that we have a common factor of x minus 3. That's where our hole is going to occur. Okay, so when this is going to cross out a common factor, we're going to get x plus 3 over x plus 1. So we're going to have a hole. The 0 of your x, which is 3, is the x value of our hole. To find the y value of the hole, you plug your 3 into the simplified version. All right, so we're going to find the y value of our hole. We're going to plug 3 in for our x and get 6 over 4, which is 3/2. So at the point 3 3/2, there's a hole in our graph. All right, please write some notes here or draw your arrows or something. So like I said, a lot of people can't remember how to find the y value of that hole. Now, because this is a hole in a graph, this is going to be a restriction on our domain and range. Please add domain and range to your notes here. So here, I know because x is a hole, so x cannot equal 3, and y cannot equal 3/2 for my range. Now, we may have other values that we add to that, but that's another common mistake people make, is to forget to include your hole as part of your domain and your range restrictions. So let's start graphing this thing. So at 3, 1.5, 1.5, there's actually a hole in our graph. So put an open circle there to represent that hole. All right, so now we won't always have a common factor. All right, step number 2, graph the asymptotes. Well, looking back at number 2, all right, once we've taken out our hole, so we did number 1, once we've taken out our hole, now we have a non-removable discontinuity, any zeros of the denominator. Now you can't, once you're a hole, that's all you are. You can't be a vertical asymptote and a hole. All right, so whatever's left once you simplify these things in the denominator, that's going to give you your vertical asymptote. So it's the 0 of the denominator. So I have a vertical asymptote at x equals -1. So that's going to be a restriction on my domain. All right, horizontal asymptote. All right, notice here to find my horizontal asymptote, notice that my degree of my numerator and the degree of the denominator are the same. An easy way to do this is to make a ratio of the lead coefficient over the lead coefficient, as long as the degrees match, and then simplify. Well, this simplifies to 1. So that means my horizontal asymptote is at y equals 1. So let's put that in there. So y equals 1. All right, so let's graph what we've got here. Let's graph x equals -1. So we dot it in because it's an asymptote. And y equals 1. Okay? All right, some things I know about this graph. Because I have one vertical asymptote, my graph is going to have two pieces. Two pieces that are going to be rotationally symmetric. Okay, so in the way they're going to rotate about where these two asymptotes intersect. Okay, so I know I'm going to have two because I have one vertical asymptote. I'm going to have two pieces to my graph. If I have two vertical asymptotes, I'm going to have three pieces to my graph, and so forth and so on. All right, let's find the x-intercept. So looking back at your guidelines, this is number 4. The x-intercept is the 0 of the numerator. So what makes your numerator 0? Well, -3. So -3, 0 is an x-intercept. Go up to step 3. All right. What's a y-intercept? You're going to plug 0 in for your x's. So y is equal to 0 plus 3 over 0 plus 1, which is just 3. So 0, 3 is a y-intercept. All right, so let's graph what I've got and see what else I need. I want at least 3 points in each piece of my graph. Okay, so let's graph. So now we're up to step 3. Let's graph our intercepts. So I'm going to graph -3, 0. That's a point. And 0, 3. All right, because I've gotten points here, I'm counting from my origin. Okay, now step 4, rotate the points. All right, so now because this thing has rotational symmetry, I can get more points from the ones I have here. I can rotate these points. Now this is a full point. Okay. All right, so let's rotate that. Now when I rotate points, you need to count from where the intercepts intersect. So I'm putting a star by step 4, not counting from the origin. So this goes right 1 up 2. So that means I'm going to go left 1 down 2 is going to be another point on my graph. All right, counting from here, this goes 1, 2, 3, 4, up a half. So I'm going to go left 1, 2, 3, 4, down a half. Now it's no longer a hole, it's actually a full point there. All right, so this is going to give me that piece of my graph. Respect those asymptotes. All right, I need another piece over here. Let's see what I didn't rotate. I can rotate this point. So what is it? It's left 2, down 1. So I'm going to go right 2, up 1. And here's the other piece of my graph. Now make sure you skip over the hole. Make sure it's obvious it's a hole. If you want to do it in a different color, that works too. All right. So here's the graph of this case 1. Now let's take a moment. We got our domain restrictions. We've got our hole domain and our asymptote domain. Let's look at our range. We've got our restriction on our y for a hole, but we didn't get the one on the horizontal asymptote. So y cannot equal 1. So my domain is all reals, but x can't equal 3 and x can't equal -1. And my range is all reals, but y cannot equal 3/2 and y cannot equal 1. All right, so there's a case when you have a common factor, which is a hole in your graph. We're going to look at 2 more cases today. It's all about knowing those guidelines. All right, let's look at the second one. I'm going to follow those same steps. So the first thing I'm going to do is I'm going to factor this to see if I have a common factor. So I've got 2 comes out, x plus 3 over x minus 4. All right, no common factor. That means I don't have a hole in my graph. Vertical asymptotes, it's the 0 of the denominator. So x equals 4 is a vertical asymptote. All right, horizontal asymptote. Look at the degrees here. They're both degree 1. So I'm going to match up my degrees. So 2x over x, and then reduce this. So y equals 2 is my horizontal asymptote. So let's graph our asymptotes. So x equals 4. And y equals 2. Okay? All right, let's find our x-intercept. X-intercept, it's the 0 of the numerator. So what makes my numerator 0? Well, that's negative 3. So negative 3, 0. My y-intercept, I'm plugging 0 in for my x's. So I get 6 over negative 4, which is negative 3/2. So 0, negative 3/2. All right, let's graph what I have and see what else I need. Remember, I want 3 points on each part of my graph. Because I have one vertical asymptote, I know I'm going to have 2 parts of my graph. All right, so I've got negative 3, 0. Counting from the origin here, negative 3, 0. And I've got 0, 1, negative 1.5. So there's another point. All right, let's rotate those points. Now remember, I'm counting from where my, I'm counting from where my graphs intersect. So I'm counting from this point here. All right, so what have I got? I'm going to rotate this point. So I've got 1, 2, 3, 4, 5, 6, 7, down 2. 1, 2, 3, 4, 5, 6, 7, up 2. It's going to put me there. Change it back to blue. All right, let's rotate this point. It goes 1, 2, 3, 4, 1, 2, 3.5. 1, 2, 3, 4, 1, 2, 3.5. All right, I need one more point. All right, I'm going to pick a point in here because I need to figure out how fast is this thing going to get to this asymptote. So I'm going to split the difference here. So I'm going to plug in x equals 2. So if x equals 2, I'm doing test points now. What does y equal to? Y is going to equal to, plug in 2 for x. It's 2 times 2 plus 3 over 2 minus 4. So you're going to get 2 times 5 over negative 2. So that means y is negative 5. So 2, negative 5 is another point on my graph. Now since I plugged it in, I'm counting from the origin. I only count from where my asymptotes intersect if I'm moving points that I already have. All right, so 2, negative 5. All right, so there's one piece of my graph. Now I'm going to rotate this point that I just found. So I'm counting from my asymptotes. So left 2, down 1, 2, 3, 4, 5, 6, 7. So 2, 1, 2, 3, 4, 5, 6, 7. So there's the other piece of my graph. And I know it had 2 pieces because I had one vertical asymptote. All right, let's do domain. We don't have a hole, but I do have a vertical asymptote, so x cannot equal 4. So negative infinity to 4 union 4 to infinity is another way of writing this. My range, y cannot equal 2. So negative infinity to 2 union 2 to infinity. I'm skipping over my 2. All right, so there's a case where my polynomials do not simplify, do not have a hole. All right, let's look at one more for today. All right, how does the degree of each polynomial help? All right, let's see, same thing. Step number 1, I'm going to factor my numerator and my denominator. So when I factor this, well, there's nothing to factor the top. So what multiplies to give me negative 6, but has a difference of positive 5? So that's going to be 6 and negative 1. Alright, so factor this by grouping if you need to stop the video for a bit to factor. But when you get done, you should get 2x minus 1 times x plus 3. And always take a moment to make sure you factor it correctly, because nothing else is going to work if you don't factor correctly. Alright, whole. Whole is a common factor in the numerator and denominator. Well, this doesn't have a common factor, so that means it doesn't have a whole. Vertical asymptotes. It's the zeros of the denominator. Well, this thing has two zeros. It has x equals 1/2 and x equals negative 3. So we have two vertical asymptotes. All right, horizontal asymptote. All right, we haven't done one like this before. Look for your horizontal asymptote. We want the degree. The highest degree here is x squared, so 2x squared. And you have to match the denominator to the numerator. Well, in the numerator, our highest degree is x. We don't have an x squared, so we have to put in a 0 placeholder for our x squared to use this method. And if you reduce this, you're going to get y equals 0. So the horizontal asymptote is y equals 0. So step number 2, let's graph our asymptote. So we're going to graph x equals 1/2. And y equals 0. You can dot it if you can't see it. You can make sure, just like I said, so the x-axis is an asymptote in this case. All right, we also have the vertical asymptote at x equals negative 3. So let's make sure we graph both vertical asymptotes. Okay, this is going to be the most labor-intensive one that we got. We're probably going to have to do a lot of test points because we have two vertical asymptote, my graph is going to have 3 pieces to it. And unfortunately, I can't rotate. It's not going to have rotational symmetry anymore. I can't rotate to get those other points. So I'm going to have to do a lot of testing to get a good graph. Remember, so since I've got 3 pieces, I want 3 points in each piece of my graph. And I'm going to have to use my points to help me figure out where my pieces are in my graph. Okay? Alright, so let's go back and let's find the intercepts. X-intercept is the 0 of the numerator. So that means negative 1, 0. My y-intercept, I'm plugging in 0 for all of my x's. So my y-intercept is negative 1/3. So 0, negative 1/3. Okay, so let's graph. So what I'm going to do is I'm going to have some piece somewhere in here in the middle, and then I'm either going to have pieces, depending on what this middle does, I might have pieces here and here, or here and here, or here and here, or finally here. I won't know that by looking at this. I need to plug in points to figure out where I've got those points, and that's going to help me with my pattern. Like I said, this one's going to be a little bit labor intensive. All right, so let's graph what we've got and figure out what we need. So I've got negative 1, 0. Now notice that this thing, there's a special case too. Notice that I'm touching the horizontal asymptote. That can happen sometimes within the graph. The end behavior is never going to touch a horizontal asymptote, but within the body of the graph, it can cross a horizontal asymptote. You're never going to cross a vertical asymptote. But sometimes you can cross a horizontal asymptote. It's the end behavior that's never going to cross a horizontal asymptote. Lots of things to remember. Like I said, we're getting into that more complicated part of our course. Okay, so we graph negative 1, 0. Let's graph 0, negative 1/3. Okay, so we're here. About. Okay, let's work on that middle piece of this graph. Now, it's going to do one of two things. It's either going to flip down like this, sort of like a parabola, or it's going to come in here like sort of like a cubic graph. Okay? But I can't tell that by just looking at this. I got to plug in a point. So let's start easy. Let's start with x equals negative 2 and figure out that middle piece of my graph before I move on to do anything else. All right, so x equals negative 2. And you may need to get another sheet of paper to do this work on. Like I said, make yourself nice and organized because this is what you're going to have to do in a graded situation. All right, let's plug in negative 2 in for my x's. So negative 2 plus 1. 2 times negative 2 is negative 4 minus 1 times negative 2 plus 3. All right, do that math and you should be getting 1/5. Since positive 1/5. So since I'm plugging into a point, I'm counting from the origin. I'm plugging into the original graph. All right, I'm not going to get to rotate any points, unfortunately, on this. So this thing is going to go left 2 up 1/5. So there's the first piece of my graph because it's going to respect those vertical asymptotes. And now because I've done a number of these and it's all about recognizing patterns, I know now that my graph is either going to be in these two quadrants here and here or here and here. All right, so now I just got to plug in enough points to get enough of the rest of my graph to be able to find the rest of my points. All right, doesn't matter if I start on the left or start on the right. I'm going to start on the right here. All right, so I'm going to plug in x equals 1. I'm just working my way. I'm going to have to plug in 3 points here and then 3 points to find the points over there. All right, so let's plug in x is equal to 1. All right, plugging in 1. So we got 1 plus 1. 2 times 1 is 2 minus 1, and 1 plus 3. So you should be getting 1/2. So let's graph that. So 1/1/2 is a point. All right, let's keep going out. Let's do x equals 2. So y is going to equal to plug in 2. 2 plus 1 is 3. 2 times 2 is 4 minus 1 is 3. And 2 plus 3 is 5. So this is going to give me 1/5. So 2/1/5 is a point. Well, you see I'm just getting closer and closer to that horizontal asymptote. All right, so I know my graph is just going to do like this, hit those points. So the end behavior is it's not going to cross again because this is the end behavior. It's not going to cross that horizontal asymptote, and you never cross a vertical asymptote. So I really only needed 2 points for that one. All right, let's work on that left-hand side. So let's plug in negative 4 because that's the next smallest value on my x. So let's plug in x equals negative 4. Like I said, this one is going to take a little bit of time, math, labor-wise. All right, so let's put in negative 4. Negative 4 plus 1 is negative 3. Negative 4 times 2 is 8 minus 1 is negative 9. And negative 4 plus 3 is negative 1. So I'm going to get negative 1/3. So negative 4, negative 1/3. And I think 2 points are going to be enough for me here too. So let's do x equals negative 5. All right, plug in negative 5 into this original up here. Negative 5 plus 1 is negative 4. Negative 5 times 2 is negative 10 minus 1 is negative 11. And negative 5 plus 3 is negative 2, which is going to give me, when I simplify that, negative 2/11. So barely below. So negative 5, negative 2/11. So here again, let's respect our asymptotes. So there's a picture of that graph. So like I said, recapping again, because I had 2 vertical asymptotes, I know I'm going to have 3 pieces to my graph. And sometimes, all right, you can cross a horizontal asymptote within the body of the graph. The end behavior won't cross a horizontal asymptote, but sometimes in the middle of the graph or in the body of the graph, it will cross a horizontal asymptote. All right, and then your graph will never cross a vertical asymptote. All right, let's finish this up with domain and range. All right, domain. All right, I don't have any holes, but I do have asymptotes. So x cannot equal 1/2, and x cannot equal negative 3. And my horizontal asymptote is y, so y cannot equal 0. So my domain is all reals but 1/2 and negative 3, and my range is all reals but y cannot equal 0. Okay? All right, if you have any questions, please make note of the questions as you come through them so you can ask them in class.